Welcome in the session of Engineering Materials and Metallurgy. Today we will discuss about the metal deformation. So we know whenever we apply the load or force on any material, so there is a change in the shape and size of that particular material. When we apply the load, that phenomenon is known as the deformation. So the material is going to elongate with respect to the certain length. That is also called as a deformation. So why metal deformation occurs? Because whenever we apply the load or force on a material, it will get deformed due to its property or nature. So there are two types of deformations are there which are seen in the metals. One is called as a elastic deformation, and second one is called as a plastic deformation. So these are the two types of deformation that are seen in the metals. One is a elastic deformation and second one is a plastic deformation. Now we will see in detail what is meant by elastic deformation and what is meant by plastic deformation. Before going to see the elastic deformation and plastic deformation, we must know the nature of the stress strain curve. So this is the diagram or a typical stress strain curve for a ductile material, which shows the both the type of deformation included for the metal, that is nothing but elastic deformation and plastic deformation. So here you can observe on x-axis there is a strain, that is nothing but a percentage of elongation or percentage of deformation you can see on x-axis. That is represented by small e. So strain, that is a change in length per unit original length is a percentage of elongation. Then on y-axis we will observe the stress, that is nothing but applied load in Newton per meter square or Newton per mm square, or we can consider the stress in the form of load also in Newton or kilonewton. So stress it is denoted by a symbol that is a sigma. So that will be represented on y-axis. Now we are starting from the zero loading condition. Whenever there is a no load applied, the deformation will be equal to 0. So as we can increase the stress or load value, it will start the deforming. So at this point A, the material shows the proportional limit. That is nothing but a Hooke's law is obeyed here up to point A. It means that the material is in elastic behavior. Means whenever we apply the load, material gets elongated, and after the removal of the load, it gets the original shape and size or original dimension. Such a behavior of the material is called as a elastic behavior or elastic deformation. We apply the load, it will get deformed, material or metal get deformed, and when we release the load, the material or metal regain its original dimension or shape and size. Such a deformation or behavior of the material is called as a elastic deformation or elastic behavior. Next, beyond this point A, whenever we apply the load, so there will be the plastic deformation started after point A. So that region is called as a yield region or yield point, where some amount of plastic deformation is going to happen. So over the elastic limit, so there will be a yield region. We can consider it as a yield region between A to C. That region is called as a yield region, where we can observe the very less amount of deformation or strain is observed, that is nothing but 1%. So that stress is called as a proof stress value. So where permanent state of deformation can be observed. So that will be called as a proof stress. So here the between region A, B, and C, the deformation is there. That is the yield region, and beyond point C, you can observe the as the load or stress is going to increase, there is a increase in the strain value. That is nothing but a more amount of deformation is there in the material. So the deformation in the material beyond the elastic limit is called as a plastic limit. So such a behavior of the curve is called as a plastic behavior. Means in this region, uh, there is a plastic deformation. Means after removal of the load, the material does not regain its original shape and size or dimension. That's why this deformation is called as a plastic deformation. The material gets plastically deformed. So you can observe here some maximum loading condition is there. That is the maximum stress is there and maximum deformation is there. So this region is called as the neck formation for that curve. And after that, the load is going to decrease in some amount and the material will get fail with the, some amount of deformation. So here at point D, that point is called as a fracture point or failure point where the material gets fail and deformation going to stop here. So at point D. So after point A to point D, the material is in plastic behavior. Okay. So basically it is from C to D, it is a more in plastical deformation, and A to C there is a slight amount of plastic deformation is visible. So from this stress strain curve, typical stress strain curve for ductile material, we can predict or we can learn what is the elastic behavior and what is the plastic behavior of the material or metal. So here also diagrammatically you can see the deformation for the ductile material. So this is a part A, a part B, and part C. So these are the types of failure or fractures occurs in the ductile material. So cup and cone type of a fracture we can observe in the ductile material, as well as in brittle material there will be no cup and cone type of fracture is there. The material will get directly deformed with the directly failure with the minimum amount of deformation in case of a brittle material. So this is what the type of failure for the ductile material. Now we will see in detail what is the elastic deformation or what are the different parameters in the elastic deformation. So first, it takes place over a short range of stress strain curve. So as we can see that the region for the elastic deformation is very less or small length is there. So the amount of deformation is quite less for the elastic deformation. Next, it appears and disappears with application and removal of the stress. So this is also one of the important condition for the elastic deformation. So here we can see elastic deformation appears and disappears with the application and removal of the stress. Means when we apply the load or the stress, the material gets deformed, and when we release the load, the material regain its original shape and size. Next, third one is the elastic deformation is the starting of the progress of deformation. So initial deformation is there in material which is represented by a elastic deformation. Next is the strain approaches its maximum value after stress reaches its maximum value. So here in elastic region, the strain is a maximum if the stress is maximum. This is what this point can show. Next, we are having a what is meant by plastic deformation. So the first is it takes place over the wide range of stress strain curve. So you can observe the region for the curve is more for plastic deformation as compared with the elastic deformation. Second point, it is a permanent deformation which obtained even after the removal of the stress. It means whenever we apply the load, the material gets deformed, and when we release the load, the material does not regain its original shape and size. That's why it is called as a permanent deformation. Next is the plastic deformation takes place after the elastic deformation. So this is also important point. So the plastic deformation always occurs after elastic deformation. So initially there is a elastic deformation in the material, and as we increase the stress value or load value, after beyond the elastic limit, the deformation is going to start, and such a deformation is called as a plastic deformation. The next fourth point is a strain occurs simultaneously with the application of the stress. This is also important parameter, a point. Strain occurs simultaneously with the application of the stress. Means as we increase the stress, it will material will get deformed. That is the plastic deformation, and ultimately we will get the strain value there. Now we will see the what is the effect of crystal structure on plastic deformation of the material. So for any working condition of the metal, the plastic deformation is the key parameter. So the material must work under the plastic deformation so that it can efficiently work. Elastic region is there, but for the working of the material, the plastic deformation is the key parameter. Now we will see what is the effect of crystal structure on plastic deformation of the material. So the metals and alloy with FCC, BCC, HCP undergoes plastic deformation. So as already discussed in unit number one, that is part number one, we know that each and every crystal structure is formed, or each and every metal is formed by a crystal structure, which may be a face center close pack, body center close pack, or hexagonal close pack structure. So depending on the arrangement, atomic arrangement, we can classify that metals are alloy with FCC, BCC, HCP. So that depending on that crystal structure, the or crystallographic arrangement of the material, the material properties are going to change, and that material undergoes all the materials are undergoes the plastic deformation. Means the metals and alloys with these structures are always undergoes the plastic deformation. So the first step of plastic deformation is the slip. Okay, so slip of one part of crystal over another in several direction is a deformation. Then second is the properties associated with the plastic deformations are ductility, grip, response to fatigue, etc. Now we will see the mechanism of elastic and plastic deformation.